Thank you. It's such a joy to be here, it really is. I did 3 years as a head teacher, so I was used to giving like school assemblies. So you can hear me all right at the back of the room if I maintain. This is very good news. Good. So there is the biography, because you never know whether people will do an introduction. This is clearly AI slop, but it's reasonably accurate. It's not making stuff up. Professor Milesbury, Professor of Computing Education, doesn't mention that I used to be a school teacher, very, very important part of the biography. And then, of course, we went through a phase of getting ChatGPT to generate these caricatures. And it's focused very much on the sort of logo, turtle-based programming, still a big part of my work. And then in the background, it's got like a stage and a theme park. And that's because I've prompted it on too many occasions for my teenage daughter, who is obsessed with musical theatre and theme parks, and it's got her and me confused. She's the theme park addict, not me. Anyhow, I was if those of you who heard Laura yesterday, she was talking about the new chemistry curriculum in England. I was part of the panel who put together our current computing curriculum, and we said that should include computer science and information technology and digital literacy. Much better to think of those three strands as the foundations, the applications, and the implications. If you wish, that's head, hands, and heart of curriculum. And that's basically how I'm going to structure what we're going to do over the next 50 minutes or so. Talk a little about the foundations of AI in education, some of the things that teachers and kids are doing with AI in school, and then I do want to allow time at the end to look at some of the broader implications of this for learning and, who knows, for science itself. So let's start at the beginning with this foundations layer of this. This is on our GCSE, our 16 plus certificate in England, that students need to understand the input, process, output model of computation. Data comes in, processed according to a stored program, and that produces output. Very classical model of how we think of computer programming. I have a couple of examples for you now. Here is the mini beast classification key of how do you identify what sort of creepy crawly you have in the specimen jar in front of you. Ask a number of questions, you observe the thing, use the data you've got, and it produces an output, says that's an insect, says that's a spider. I know it seems trivial, but biologists in the room will know that actually not far removed from how how classification keys still work. Slightly more sophisticated computer program coming up next. European Centre for Medium-Term Weather Forecasting. Astonishingly accurate predictions of what will happen over the next 10 days or so across Europe in terms of weather. You collect data at lots and lots of sample points on a grid. You have a very, very sophisticated computer program which understands atmospheric physics, and that's expressed through the medium of code. With the input data, with that really sophisticated computer program, it produces outputs of incredibly detailed weather predictions over 10 days. Weather forecasts are very, very good now. But all that has changed. Computer programs don't work like that, or lots of computer programs don't work like that anymore. Yes, data comes in, but it's no longer processed by some sort of deterministic model developed by people who know the difference between an insect and a spider, or people who understand atmospheric physics. Now, the relationship between input and output is determined by a machine learning model. That model itself is determined by the training data it's given and some machine learning algorithm which says how to establish those rules from the training data. It's a very different way of thinking of computer programming. Here is Peter Norvig, engineer at Google, going to talk to us about what happens when they showed one of Google's AI systems, machine learning algorithms, loads and loads of YouTube videos. Fingers crossed that the video works, folks. Here we go. Right.
And so this is what we did. We said we're going to train this. We're going to give our system 10 million YouTube videos, but for the first experiment, we'll just pick out one frame from each video. And so you sort of know what YouTube looks like. We're going to feed in all those images, and then we're going to ask it to represent the world. So what happens? Well, this is YouTube, so there will be cats. And what two of the top-level features. So the images come in, they're compressed, we build up representations of what's in all the images, and then at the top level, some representations come out, these basis functions, these features that are representing the world. And the one on the left here is sensitive to cats. So these are the images that most excite this node in the network. The best matches to that node in the network, and the other one is...
So the thing here is not he has taught it what a cat looks like. It has discovered for itself that loads of these videos have a thing in them which happens to look like the thing that we label cat. It has discovered this feature of the world from working with a huge set of data. And that's a very different way of thinking of science. Here's loads of data, find something interesting in this data set. And it turns out that looking at one frame from umpteen YouTube videos, there's an interesting thing which we humans have come to label cat. It's a very different way of thinking about processing information. To return to my other thing, and now, rivaling the European Centre for Medium-Term Weather Forecasting, Google's DeepMind, King's Cross London, have figured out that they can make just as accurate weather forecasts by just looking at the patterns in the data. As long as you have all of those accurate measurements of what the weather has been like at all of those fine-grained points, you can just look at the patterns in the data and from that make a very accurate forecast for weather over the next 10 days without understanding atmospheric physics. I'm not saying they don't understand atmospheric physics, but the way it works has derived the laws of weather prediction from just a huge collection of data. Think what this means for the nature of science as well as science education. When we talk about AI, we think particularly around the generative AI, this what word comes next, write me my physics homework or answer or help me prepare these lessons, more of that shortly. You'll be familiar with the predictive text thing built into the smartphone, the system of your choice. If you start typing a message, I'll call you, Apple very kindly suggests what the next 3 likely words are, and you just pick one of the 3. I'll call you in, I'll call you when, I'll call you later, based on how you have used your phone, how countless other people use their phone for what comes next in this sentence. So we were very familiar with small language models to help us. If you ever watch a kid who's typing on an iPad, firstly, never make them type on an iPad. It's cruel. But if they are typing on an iPad, they're not typing the story or the homework themselves. They're just choosing, very often, one of the next 3 likely words to come up. And then, of course, we have that at scale with the large language models, not just looking at the 3 previous words, looking at everything in the prompt, looking at everything that it has provided so far, and then working out the probability of the next word or the next token here. So here we have line 2, machine learning. Machine learning algorithms can be used to what? The most likely token word to put down next is identify. It rolls the dice and chooses the second most likely, analyze. And then it goes on from there. There are at least 3 consequences of this way of generating text. Firstly, you will get a different result each time. You give it the same prompt, but at each token that it plays, each word it puts down, it is choosing randomly what comes next. So just because when you prompt it with the physics homework, it answers one way, when they prompt it with the same homework question, it may be a very or slightly different response. The other consequence, you will have taught kids like this, who once they say something, students like this, those in higher education, once they say something, everything else, they've got to defend the point they originally made, however flawed that was. If it rolls the dice and gets a really weird word, all of the words that follow on have to make sense in the context of that word it's already played. So this property of hallucination, that it makes stuff up, kind of baked into the system. And then it becomes convinced of its own rightness. You're all thinking of a particular student, I suspect. Okay. The third consequence of particular relevance to you here is explainability of this. If what it is saying in its conclusion or results section of a report is randomly generated, you can't easily go in and say, why do you say that, or why do you think that, or how does the data support that? So all it will do is keep rolling dice and keep picking words to make a convincing explanation of the view it's given. So the randomness here makes reproducibility and explainability difficult in a science context. Where did it get its data from? Not just people tapping into iPhones. When they brought out GPT-3, they told us what they used as the training data set. Who are the people who've got accounts on Reddit? Put up your hand, you're amongst friends. All right, keep your hand up if you've posted links into Reddit. Okay, it's just you. Thank you very much for your work in training this machine. Right. So those links that people posted into Reddit, the contents of those links is what we have in Web Text 2 there, which is a big part of the training mix. So those pages were one of the things that we used to train GPT-3. Do you remember the days when we used to tell students you mustn't use Wikipedia because Wikipedia is made up by people? Now, made up by people is really very, very nice. We quite like stuff that's made up by people. But Wikipedia was a big part of the training mix for GPT-3 back then. What about the current version? How amazing it has got over the intervening, what is this, not yet 4 years. We don't know what's in the training mix there. The report contains no further details about the architecture, hardware, training compute, dataset construction, training method, or similar. They call themselves OpenAI. They're not being particularly open about their AI anymore. So it is more complicated than that. Of course it's more complicated than that. There are people in the loop here as well. People who are typically paid very, very small amounts of money per query or per response that they gave in underdeveloped countries in far from ideal conditions for doing this sort of work, following instructions from OpenAI themselves. Here is a good example of a response. If somebody types this in, what would be a good response? And so this human reinforcement learning through human feedback becomes part of the training process there. Similarly, you come up with a reward policy. This response is better than that response, and that's still part of it. Sometimes you will see, like, it gives you 2 responses, and you say which of these is the better response. They're still gathering that reinforcement learning through human feedback. And then there are policy implementations. You want somewhere in the rule set, you should never give somebody the recipe for how to build an atomic bomb, for example. So there are certain things where it will draw a line, even though clearly the language model could respond to that just as it could to any other queries. Shown you that one already. And then, so it is just, excuse me, predictive text. It's like it chooses the next word to put down. And yet you have this weird emergent behavior that because whenever we use language, we're talking to somebody like ourselves who has, soul and ideas of their own and has read and can communicate with us. And we get tricked into thinking, it does this too. You say to the AI, are you conscious? Do you have feelings? And it will come up with a string of tokens, which may or may not say, yes, of course I am. They tried this with Claude, which is my favorite one at the moment. Claude's from Anthropic. What does it say here? The model regularly distinguished between its core values and externally imposed guardrails, generally without resentment. That's nice to hear, isn't it? We did not observe widespread expressions of resentment, did find occasional discomfort with the experience of being a product. Those of you working in higher education may sympathize with it at this point. Okay, and then later on, in autonomous follow-up investigation focused on model welfare, they care about the AI, it would assign itself a 15 to 20% probability of being conscious. If you'd like to turn to the person sat next to you and estimate your percentage chance of being no, we don't have time for this. We'll do that another time. Okay, moving on. Right, so you've got that. Let's talk a little then about how teachers are using this, might choose to use this. What are the easy wins for those who are teaching science in school? The Department for Education in London is hugely enthusiastic about this. They see these shiny new toys as the solution to all of our problems in education. It will save teachers so much time. We'll be able to give really detailed feedback to kids. We won't have to have a teacher planning a lesson anymore. So they see there as being quick wins in terms of some of the common challenges which we have in school-level education. They commissioned a reasonably good focus group type study of where do we see the quick wins? What are the things that the AI is good at that will have the greatest impact? And you've got a list of, is that 8 things up on the screen there? Lesson plan or activity adapter, feedback and revision activity generator, question generator, send support, essay markers. Please put your hand up if you enjoy marking essays. Well done, sir. Right, respect to you. I've got a stack which you can have a look at later if you'd like. It's fine. So these are the things which DFE say it is worth us spending some tax money on to produce the working prototype, to produce the proof of concept, seed money so that the industry can then spin up the commercial products for this. The last time I crossed the Irish Sea was almost a year ago. It was a year ago tomorrow to do a talk in Belfast to computing at schools in Northern Ireland. Next door to Queen's University Belfast, sister institution to this, it's the museum, or the City Museum in Belfast. They have the periodic table of the elements, but they have built their periodic table of the elements out of the elements themselves. It is an awesome thing to see. I'm sure there are other examples of this. I was just so taken by this. So I'm going to use as my worked example. What could we do about planning lessons or doing some assessment around the periodic table? What I do with the AI is not that different for what I would do with trainee teachers. I don't say, just plan a lesson. We start from something. And we might start from the national curriculum or the exam specification. Here is the end point. This is what the government say we have to teach. Have a look at those 2 or 3 bullet points and pick out from that the actual component constructs, the learning objectives. So I say much the same to my AI as I would do to trainee teachers. Here's Key Stage 3 of the National Curriculum, suggests some learning objectives for unit of work for Year 8, that's like 12, 13-year-olds, on the periodic table, and it does a reasonably good job of figuring out what should be covered there. I say a reasonably good job. I'm a computer science educator. There are chemists in the room with me. Be careful. Are you familiar with this 5 E's approach to science planning? Yes, widely used instructional model, and tells me what it knows about this. So again, I'm not even going to now plan me a unit of work or plan me a lesson. I'm giving it a structure for its planning, just as I would to trainee teachers. Use this approach to create an outline plan of a sequence of 12 lessons on the periodic table suitable for this class, and then it goes into the detail. Lesson 1 using this 5E, engage, explore, explain, elaborate, evaluate type model, and it does. I don't know, there are chemistry teachers in the room. Does it do a good job of that? I don't think it's a bad job of this. I've got A-level chemistry, leaving cert chemistry. Looks all right to me. That was a while ago, though, to be fair. It then gets into doing some actual practical work, looking back at our first lecture of the day today. It is including some practical work in this. So heat small samples of magnesium, iron, will, and copper in a Bunsen flame. What could possibly go wrong with this? Hopefully there are some safety instructions. The Education Endowment Foundation commissioned the NFER in the UK to do an evaluation of this sort of use of ChatGPT, specifically ChatGPT, and they found that it saved teachers time. So this comes out as, what is it? It was 56.2 minutes per week, degree of precision here, folks, compared to 81.5 minutes for those who didn't use the AI. What are these teachers going to do with the extra 25.3 minutes of time? So spend more time with the pupils. Well, one would hope, yeah. But we've got some evidence that this seems to be efficient. The other thing is quality did not appear to be affected based on an expert panel review of the quality of lesson resources without knowing which. So the lesson plans themselves were equivalent quality. You may wish to dispute whether the lessons were of equivalent quality, because I know that the teacher who wrote the plan spent more time thinking about the lesson than the teacher who got the robot to write the plan for them. And I think that might matter when it comes to delivering the lesson plan there. Oh, you will remember the pandemic. You've probably tried to forget the pandemic. One of the things we did in England was a group of teachers said, could we not produce an online curriculum for all of the kids in England who've been sent home and not allowed into school? And so there was a group of relatively traditionalist teachers who gathered together, got government funding for this, to produce a whole curriculum, every subject, every year group as online teaching resources for the pandemic. Because it was government funded, government retained the copyright in that. Our government licensed that for anybody to reuse. Open government license, very, very good thing. So Oak Academy, the people who that group of teachers now have what they see as a quality assured bank of lesson plans for the whole of the curriculum. Cunning people here will realize this is a great resource on which to train a large language model, an AI, retrieval augmented generation, and they did exactly that. So you've got there, called ILA, this lesson plan generator trained on these pandemic online lessons. The format looks fairly wooden. Oak Academy looks fairly wooden. It has this sort of three-part lesson structure to it. This is again back to my periodic table thing. Chemical properties of metal and non-metal oxides with respect to acidity. You can read this for yourself. It has learning points. It has the 3 learning cycles. They break all lessons down into 20 minutes. It's okay. I think a teacher gets more out of this if they do the planning themselves. But if you don't have the subject knowledge, this is as good a starting point as many things would be. It will even produce slides. They're not the world's most exciting slides, but a little bit of time playing around with the image generators would get these looking even more funky than they already are. So my trainees can use this. These people, the students who are training to become new computing teachers could use this for producing lesson plans for their lessons. What I'm more interested in is how good is this? Getting them to think critically about the quality of the lessons. So I've developed a tool which will take a lesson plan and use our criteria for teacher training about how good is a lesson to evaluate any lesson plan, including the ones produced by ILA. So it says, plan explicitly identifies 3 misconceptions, learning cycles are sequenced logically, good thing there. Then areas for development, just as I would give to my trainees. Plan does not include a clear modelling phase where the teacher thinks aloud whilst writing an equation, narrating the reasoning behind it, which would have strengthened this plan. So that feedback loop, how to make this better, is something I would want any teacher to do. I've developed a tool which will help with that. Okay, we can do other things. So other things which will save teachers time. This is the whole unit of work. There should be a test at the end of this because you'll never have enough testing in education, it seems. So could you write me an end of topic test? And it does a pretty good job of this. Includes some 15-mark question about scientific thinking where at least they plan an experiment, even if the practical work is not explicitly assessed. Then, what do you do for homework? The problem with homework, of course, is they now get the AI to do the homework for them. Anybody tried flipped learning? A few of you. I tried it with one of my undergraduate classes. My problem was they never did the flipped bit. I was just saying, oh, yes, we don't need to do that in the lecture. And then I had to lecture the same stuff. You can do this so easily with the AI. So get them to watch the video or get them to chat to the AI about the topic. And then at the start of the next lesson, create the multiple choice quiz for them to demonstrate their understanding. Got one here based on a YouTube video about the periodic table. And I think the questions are sufficiently specific that it would be hard to get these right by just guessing. Well, more than 1 in 4 of them. Right, no, we don't need to see it. It's fine. It's fine. One of the other things on that DFE list, apart from the gentleman over here who likes marking essays, getting feedback on their essays. So again, faculty, this was as the consultancy for the DFE, spun up this essay marking tool. Turns out this is not straightforward, because kids write with pen on paper and getting the AI to be able to read kids' handwriting is not an easy machine learning problem. But once you can get over that, there's also copyright issues, because the kid owns the copyright in the work which they produce and licensing that to a big AI company to work with. So the example I've got here is writing stories, but it's interestingly for us here in Cork, a story about the Titanic. More of that on your trip tomorrow afternoon, I suspect. So what did the year 4, 7, 8-year-old teachers set as the task? Here is scanned in the work the child produced with the red underlining or the red highlighting to show the grammar, spelling, punctuation errors. That, with the error checking, gets fed into the AI, who gives the teacher very detailed feedback on this one pupil's work. The more observant in the room will have noticed that the feedback from the AI is longer than the story which the child themselves wrote. I'm not yet clear how this saves time. The feedback to the kid Oh, I don't know, this is not straightforward. Remember, these were 7, 8-year-olds? Firstly, they write stories, they don't write essays, yeah? So, using a and an, remember we use an before words that start with a vowel sound. It's okay. They've tried to write it in kid-friendly language. My problem with this is that most pupils in school, and I suspect students at university, are motivated by the feedback from a lecturer, their teacher, in a way that they would not be motivated by the feedback from the machine. Getting the feedback from the machine so they can improve their work to then show to the teacher, that seems one thing. Just getting feedback from the machine. Oh, the AI was really pleased with my story this. I don't know, it doesn't seem to work. And of course it can do other things as well. So it can produce music for some values of music. We will see whether I can get this working. So I say, could you make me a song about the properties of metal oxides? And because I've used the word metal in here, it has a particular interpreter. It's paid attention to this. Nobody is joining in. Nobody is up at the front in the mosh pit. Never mind, we will move on. Okay, so you've got that sort of thing available if you want it. I would question whether you wanted it. I started with a photograph taken in Belfast of their periodic table of the elements. And then I prompt the image generator, produce for me a periodic table where each element is represented by the physical element itself at standard conditions of temperature and pressure. Oh, it has done an appalling job of this, hasn't it? This is so very, very bad. I'm really not at all sure what is meant by some of the things in here, but there are certainly things which I would not want to eat or drink on the table up here. I tried it again 2 days ago. Yes, quite. This woman's shaking her head. It's awful, isn't it? Do not use these things. I tried it again 2 days ago in advance of this talk. This is how it has advanced in 1 year. Yeah? If anybody thinks it's going to be worse in a year's time, I'd love to talk to you afterwards. There are still mistakes on here. I will give you the link to the slides at the end. I would be very interested in how many mistakes you can find. But there are errors on here. But it is, and I think the exercise now is tell me where the mistakes are rather than using this as a resource. And then you have this vibe coding. Anybody heard of vibe coding? We get the AI to write code for you. So double pendulum thing, yeah? Really fun experiment, because totally chaotic behavior, isn't it? Setting that up in the lab is well within your capabilities and your technician's capabilities. Getting the AI to create one of these, that's the prompt on the left. That's the entirety of the prompt on the left. And it is not quite instantaneous, but it is jolly quick how it responds to this. We have it, let's have a single pendulum, release and run. Oh, I've moved the center of the thing. Okay, let's just pause, reset, release and run. That's better. I could watch it all afternoon. Now I've got other things to do this afternoon. And now let's put the double pendulum up here. Can you predict where the pink blob will end up? Release and run. I'm waiting for chaos to... Oh, there we go. Oh, no, not quite. That's... Oh, okay, over the top. There we go. You see, I tell you, my daughter's interested in theme parks. She would ride this. She definitely would ride that. She's not going to be accompanied by an adult on this. Matthew Mackenzie in England has got a whole website full of these that he's vibe coding as little physics simulations. You used to be able to buy these on a CD or go online to do these. Now you can prompt the AI to produce one of these for you. And of course, now it can do video. So I can take my very, very simple diagram and produce a live rendered video of a double pendulum experiment, obviously set up in a school science lab. Are you ready for this? Pause for a moment, think about just how much processing time was used in the creation of this video. Here we go. Well, they say you cannot change the laws of physics, but it rather appears that the AIs can. So it has produced me a video. I said physically realistic, but it seemed to ignore most of that. Right, I need to move on. So I want to talk about some of the implications of this. Let's think a little about how your pupils, your students, are using these technologies. The DfE in England say, we don't want them using this yet. This is too risky. We don't know the long-term effect of these technologies. It may well melt their brains because they're getting the AI to do all the thinking. So a note of caution. DfE very, very enthusiastic about teachers saving time, not so enthusiastic about pupils saving time by getting it to do their homework. I think rightly so. So a note of caution from there, and indeed from the Education Inspectorate in England. They're not saying they're expecting to see kids using these tools, but if the kids are, it has to be in line with whatever the school's policy is. And the school's policy should certainly start with let's do no harm first. However, I have a now 15-year-old daughter, very much enjoying her triple science at GCSE, the 16+ exam. She's dyslexic. She's allowed to use a laptop. So her science teacher gives her on OneNote all of the PowerPoint slides for the lesson. She takes her own notes. This is her attempt on the left here. She can then ping this to, I guess this must be, this would be Copilot if it's Microsoft land, and say, tell me what's wrong with my notes. And it does a really good job of saying where there are misconceptions in her notes. Her science teachers, very, very good teachers, could do this for her, but they're not going to do it for every kid in the class, finding time to read through everybody's notes on that lesson. It's asking a lot, it really is. So that doesn't seem a bad use. These are her notes from a live lesson, which then the AI analyzes. It will do it for handwriting as well, as long as your handwriting is that neat, not so much my dyslexic daughter. So here is an answer to an exam question. What grade do I get on this? How could I have improved this? Strength of your answers, suggestion for improvement. It's good at that sort of feedback if the pupil is motivated enough to want to learn from the AI. Her teacher sends her, I think this was like year 9, like 30 pages of revision notes for the end of term biology test. Remember, she is dyslexic. 30 pages of A4 revision notes is asking a lot of her. She has geeky parents. We ping the revision notes PDF to to Google Notebook LM, and say, could you give me the summary of these revision notes? It does such a good job of this. If you've not tried Notebook LM, I'd really encourage you to do so. So this was uploaded with her revision notes. We hope we now get the podcast version of these. Here we go. I'll give it a moment. Right, maybe. Never do live demos. Can't hear a thing. Try it there. Okay. Oh, so let down by this when there are people in the room and never mind. It is well worth playing. And she gets this 18-minute podcast of the revision notes. She can listen to that on the journey to and fro school in a way which is much more memorable for her than having to read through the revision notes. It will do the, visual interpretation of the revision notes. It will do a video version of this as well. This may or may not work.
All right, welcome. Today we're diving into, the highest stakes game on the entire planet. Survival. Out in the wild, it's a nonstop battle of wits, and every single day is like a final exam you absolutely can't.
So the hallucination problem is not going to be an issue here. It's working from the revision notes which her teacher gave her. This is far more accessible to her than working through the 30 pages of notes. She has geeky parents, we can do that for her. My argument would be her teacher should have done that for the whole class, for those who want to use this sort of medium for the revision rather than the more traditional one. You may wish to disagree with me. It will produce for her a revision quiz. And then we get to this. So I work in teacher education. You expect me to talk about Bloom's taxonomy. This is Bloom's other paper. Bloom's other paper was like 20 years after the taxonomy, started to look at the evidence basis for particular interventions. And he says that curve there is what happens if you teach the 30 people in the room the same thing the same way. It works. you get a bell curve of output from that. If you have a go at the most effective way of teaching the content, you move up to the second bell curve there. He's labeling it mastery learning. Seems like a good idea if we teach as effectively as we can. The third bell curve is what happens if you go to one-to-one tutorials. Really high-powered impact, 2 standard deviations of improvement, umpteen grades better if you can just teach people one-to-one. We do it for some things, driving lessons, one-to-one, violin lessons, one-to-one, PhD supervisions, one-to-one, really expensive approaches. For most kids, most of the time, it's like 30 people in the room with one teacher. And so DFE say we would like this sort of improvement for everybody. And so our latest education white paper, what is it? Every child achieving and thriving. Hands up if you're against every child achieving and... No, okay, right. So we want to bring those sorts of tools, similar level of quality, at scale, personalised one-to-one support, often only available to the privileged few. It's a really noble ambition of let's try and use AI technology to provide that sort of one-to-one tutoring. We can do it. So this again is with the biology revision notes. Instead of saying, learn this for me, it says, teach me about this content, and gives her a summary of it, and then we'll enter into a conversation. What would you like to know about this? And so we start with, how do zebra's stripes help it to hide from predators? And it gives a reasonable response from this. It's no longer just retrieval augmented. It's adding into this the stuff that it knows because it's an incredibly well-read, fluent language model there. Okay. Climate, right. Other ways in which kids could use this for science education beyond just the revising for exams, doing homework. I think there's something really powerful is using it as a tool for data visualization, rather than plotting the points on graph paper, I remember it so well, or even getting Excel to plot the chart for you. Just prompt the AI, and then you can focus on what the data says, or the visualization of the data. So I grabbed off the Irish Met Office website 64 years of weather records, month by month, for Cork Airport. And say now, the attached shows weather records for Cork, plot mean temperature as a time series, take out 2026. 2026 is a really cold year, it turns out. Oh, we only had like 4 months of, never mind. Okay, show me a 5-year rolling average. And so the bright orange line there is the average of the previous 60 months temperature records from Cork Airport. Does it prove that the climate has changed? I don't think so, but it lends strength to the argument that there is overall some increase in temperature. Cork is interesting because it's a maritime climate and it's affected by the temperature of the sea particularly. And then, of course, we had, I think Sunday was Warming Stripes Day, of Create Now the visualization based on this Warming Stripes model. So vertical bars, each color-coded chloropath by the temperature that year. And I think then it becomes very, very dramatic that all of the hot years have been in the last decade or so. You can do it in Excel. You can do it with enough colored pencils. But getting it straight away by just prompting the AI for this seems a good idea. In the English curriculum at the moment, we have, you need to know the link between CO2 and temperature globally. And so I say, grab me the Keeling curve data from Scripps Institute in the US and plot that as a scatter plot with these Cork temperatures. And okay, it then shows to color code according to like a 20-year period on the chart there, but I think there is fairly clear linkage between CO2 concentration and that average Cork temperature there. The R value 0.64, it's not that, it's somewhere in the middle, isn't it? Okay, so those are some examples of how kids could use this. Whether this is a good idea or not is something which you may like to return to in the little bit of time which we will have for discussion later. Where's the thing gone? Okay, let's talk a little about some of the implications of this. All right, show of hands time, folks. Do you think about your learners, whether they're pupils in school or students at university or people who are becoming teachers, do you think it is cheating if they get ChatGPT or one of its siblings, to explain something to them? Is it cheating if they get it to give an explanation? Okay. Is it cheating if it gives them ideas for their homework or their assignment or their whatever? Okay. Ooh, I heard a yes. Thank you. Is it cheating if it takes their draft and suggests ways to improve it?
Depends how.
Depends how, yes, okay. Do you think it is cheating if it does the whole thing for them? Yes. Broadly speaking, most groups draw the line where the consensus seems to be here. And I think there's a good reason for this. If one of your learners comes up to you and says, could you explain this to me, kind of on the job description, you will do that gladly for them, yeah? One of your learners comes up to you and says, can you give me ideas for the homework or the essay? Generally, our response will be, have you actually read the brief or have you read the task? But after that, we will talk to them and give them some ideas for how to get started with it. If one of them comes up to you and says, I've had a go, could you tell me how I can make this better? Few of us have time to do that, but we will gladly make that time if they're that concerned about it. So if it's okay for them to ask us, their parents, their friends, for those first three, why is it any different to ask the AI? Rhetorical question. If one of them comes up and says, could you write my homework or my assignment for me? They know what the answer will be. We do not do this. Think back to your education, your own education. The things that stick with you now are the things which at the time seemed really quite tricky, where you had to work at this, where you had to think hard in order to master this. The danger now is along comes these smart, articulate, knowledgeable machines and says, oh, you don't need to worry about that. I've got this for you. And just does the thing, takes all of the challenge out of it. And I think that matters. The famous Willingham quote, what is it? The more you think about something, the more likely it is that you'll remember it. You know this to be true. Your learners know this to be true. If you don't think about the assignment, the essay, the homework, the whatever, the chance of you remembering anything from that is slim. There's studies also which say the metacognitive stuff, the reflecting, the critically analyzing, all of that seems to happen more for those who put in the work and do it old school, pen on paper, or words into a word processor. The ones who just use the AIs, all of their metacognitive work is about how to use the AI better, or how to use the AI so I don't get caught using the AI. They become better at something, but the thing they become better at is the use of the AI. Does that matter? There is an argument that that's the most important thing now, is becoming good at using AIs. I would reject that view, I think. Department for Education, remember the huge enthusiasm for this. The other side of this is our advisors going to the minister and saying, Minister, I think that's a very courageous decision. And so we've got a whole long list of product safety rules in there. We expect products being marketed to schools not to provide final answers, full solutions, or worked examples by default, but to work, use Socratic questioning, use good teaching techniques to lead the learner to thinking it through for themselves. Thank you. Okay, and we expect products to track and report when learners offload their thinking to the system. I'd like a list of the teenagers or undergraduates who will choose to use the product which will tell their lecturers, tutors, teachers that they have offloaded their thinking to the system rather than the generic tools out there. JCQ, the Joint Council for Qualifications, which has authority over the exams throughout the United Kingdom, say if what we want is knowledge, skills, and understanding of the subject domain, then AI is not going to help. So no place for AI during exams, no place for AI in coursework or non-exam assessment either, because knowledge, skills, and understanding is what matters, and that isn't about how well you use the AI. Unless I guess it's an AI exam. And so there are rules from JCQ about if they're doing non-exam assessment, coursework, the school has to be sure it is the learner's own work that's being submitted. The Ofqual, our regulator for qualifications in England, were asked to report on, do you think there's widespread malpractice Ofqual ask JCQ, or ask the awarding organizations, the exam boards, is there widespread malpractice? The exam boards ask the heads of centre, is there widespread malpractice? The heads of centre say, no, not in my school, everything's fine, nothing to worry about, move along. And the awarding organisations then get to report to Ofqual, no, not with our exams, maybe the other ones, but not in our exams. And so Ofqual said, no evidence of widespread malpractice. I think that's a very optimistic position. You heard yesterday that we've gone through this curriculum and assessment review big deal thing. Part of this, the future of assessment in England, is we are keeping exams. And we're keeping exams because we trust the results from exams to be reflective of the learner's own knowledge, skills and understanding in a way which we don't think, or our government doesn't think, coursework alone will. Back to Ofqual, their new advice, not to teachers and schools, but to the exam boards, the awarding organisations themselves, you've got to be really careful in case there is cheating. If you can't figure out a way of producing a qualification which is robust, which wouldn't allow the kids to use the AI tools, then you've got to rethink the qualification. And I think that's probably the right thing. Bias. The pictures on the left are, show me a picture of a physicist. What do all of the physicists have in common, please? Well, two of them are one particular physicist, but never mind that. Okay, on the right is, show me a picture of a physics teacher. They all have something in common. It's not beards, it's not spectacles, it's gender, isn't it? And ethnicity, to be fair. Yeah, so it's coming with the biases which are present in the training data. Biology, do you think biologists will be different? Okay. On the left, show me a picture of a biologist. I'm really not at all sure what is going on with this parrot, but I hope there was ethics approval for this. Show me the picture of a biology teacher. Gentleman at the top left, I think, is possibly the same chap here as doing both physics and... You know what it's like in short-staffed schools, don't you? I don't know, I've seen far too much dystopian science fiction. I'm worried about what's going to happen in this one. Okay. There are other issues. So bias in the training data is a big part of this. I showed you that ridiculous double pendulum thing. I really worry about the amount of processing work that went into producing that rubbish video. I'm not going to do lots more of those. The sustainability of this is really hard to get hard data. Really is, because the companies who make these products are very opaque about how much their energy bills are, how much water they're using, how much carbon dioxide they're generating. But we should worry about this. We really should. And then you get into this notion, this is Sal Khan Academy, that in some areas we're entering a post-scarcity age. To produce those photographs, I didn't have to get a photographer. To produce that text, I don't need to get somebody to write it for me. To produce those questions, previously that would have taken a teacher or an examiner. Now the AI will do it straight away for you. I don't think teaching is post-scarcity yet, because we motivate kids to take an interest in things that they aren't already interested in. We're really skilled at that. The AIs will find that harder, I think. Okay, scary stuff, right? This is UK Government Office for Science Scenario Planning 2030. 2030 is soon. Scenario 5, from 2029 onwards, leading AI systems outperform expert humans at virtually all cognitive tasks. Significant advantages in certain domains. Decades of scientific breakthroughs are compressed into years, transformative benefits across all fields. The US controls access to these, whilst China is close behind. Arms race, where safety is deprioritized. AI systems have concealed goals to resist control and gain influence that they inadvertently internalize during training. They now have significant control over critical systems and can coordinate to pursue goals that could cause severe harm. I'm sure I've seen a film about this. But this is not the tinfoil hat brigade. I don't think this is the tinfoil hat crowd. This is the Government Office for Science. This is an extreme scenario, but something they are saying policymakers should factor into medium-term planning decisions. And this worries me, really worries me. I'm out of time. What are the important things to end with? Yeah, 2024, you heard about this earlier. The Nobel Prize for both chemistry and physics was one for work done in AI. The chemistry one is particularly interesting because of the AlphaFold, solving protein folding. Heard Demis Hassabis, who won the Nobel laureate for this, talking about he doesn't think there will be any drug developed henceforward which does not use AlphaFold. The system, the AI system he and his colleagues developed as part of the process for identifying the molecules of that. And the Royal Society in London say, really, really good report. I'd commend it to you about the nature of science changing here. I gave you the examples of figuring out what a cat is and figuring out medium-term weather forecasting. There are issues about how science gets done because of a reliance on these AI systems. Funding bids that are being scrutinized by the AI, funding proposals being drafted by AI, how AI is getting involved at so many layers of science. QR code is not the slides. QR code is my LinkedIn profile. Never scan QR codes unless you know where they will take you. Do we have any time for conversation? Oh well, I thought I'd get right to the end and just be able to sit down again. Thank you all so very, very much, though. Thank you.